I'm coming from the American University of Science and Technology. I actually work, my main work is at AUST is security, network security, information security, mobile security, and everything related to security. So today, I hope that I want to show you something beautiful here. You will, of course, like it. Very high, this one. So our outline, or my outline, can I take this one and oh, so
yeah, you can take it.
can I take this one? It's better for me. And I get used to explain in front of my student. Okay, my outline is no problem. So I will show you first some live attack demo that are currently happening instantly. Introduction to software security, industrial control systems that is already installed here at the university, the ICS architecture and security issue, IoT environment and architecture, IoT protocols and security concern, and an example of some IoT applications. First, you see, this is our city, for example. People are happy, students going to university, the children playing, chatting, working with their iPad and everything. Suddenly, we have to see the following. Just 1 second for this page to load. Instead of waiting, we can open another page. Is that okay? What is this here? Is this working? Just I want to show you live demo about the threats that are happening now. But it's, I think this is a problem.
We have cyber attack.
It's okay, huh? So I want to show you, look at those attacks that are happening now, actually. So, I know what I think that our smart city, we have many challenges in order to secure our smart city. You see, those are the live attacks that are happening now. I don't know actually why people attack each other. So now we are going to protect ourselves here in a way that somehow nobody can actually interfere. So we have another website here. Hope that it will open. Maybe it's better than this one. Okay, this is the attack here. Here you will have here the attack origin coming from Saudi Arabia, China, United States, wherever. But I saw France before here. Maybe now they are not. Who knows? Those are the attack types, denial of service attack. This is France, I think. Attack target, you see?
Yeah.
This is the attack target. Those are actually the live attacks that are currently happening. So going back to our presentation. So my own concern is, first, how to define security. What does a secure system or software really mean? When we can say that a software is secure, in fact, if you can answer me, it will be great. So in fact, there is nothing secure whenever it comes to technology. So hacker always looking after us and trying to chase us by always inventing new program, new solution in order to hack us. I want to ask you a question. For example, your boss asks you to buy a secure OS. You have various choices. You have general purpose, Windows, Mac, or Linux, and a special purpose, of course, SUSE Linux or whatever. How will you decide which one to pick? So in fact, you know that Windows is a proprietary software and Mac also, but Linux is an open source software. I will recommend to use, of course, Linux. Why? Since we can customize it to our own need. It's an open source. We can write our program, our code in C and in C++ in order to make it secure for our own environment at least. Why? Since if we install Windows, for example, and a certain attacker comes in or a certain virus hits our system, it means all the Windows systems that we have it installed inside our company or network will get hacked. So that's why I recommend always using Linux and try to, of course, get used to the open source software community. Again, when can we say that a software is secure? Various criteria can be used to decide if a software is secure. Here are some. First, what goal of security does your boss want? Does he want confidentiality? It means information are secure, nobody must not see it. Integrity, everybody can see the information, but nobody must modify the information or is allowed to modify this information. For example, if I, let us say, publish my grades on the online system for my student, they all have to see their grades, but without letting anybody to modify those information. Second, do all these information are available? Do somebody is establishing a certain denial of service attack? Who knows? Authentication, do those information are authenticated? It means do they are genuine, coming from a certain legitimate party? Who knows? So it depends. What are the security policies that the manager or the actually system engineer wants? Does it implement the various security design principle and standard? We know that, and we have to follow a certain standard in order to make our system secure. We cannot rely on our own system. So standards are very important. Does it provide a historic reference in terms of vulnerability? So we have to answer those questions. All these are reasonable criteria, but not good enough. Why? There will always be something called covered channel. Covered channel, it means this is a hidden channel that always the hacker will follow in order to, of course, hack us. So what should a security expert say? Don't use, from now on, the word secure. Replace it with, actually, trust. Example, tell your boss that he or she is not looking for a secure OS, but a trusted OS. Why trust different from secure? Because word secure reflects a dichotomy. Something is either secure or not secure. That's what I mean by secure. On the other hand, trust gives allowances for approximation. Example, trust imply meet current security requirements, cannot speak about the future. So we are now trusted, but tomorrow we are not. So we cannot say now we are secure. If we implement security, for example, for 1 month, no, you cannot say it's secure. Nobody knows. So this is actually our campus here. And here, when I made my research, I saw, let us say, or I detected, those are the posts that we have here at University of Lille. So I'm going to propose my own network, my own secure network. Why? My work starts off when our colleagues finish. So they, let us say, implement or install all their sensors that are related to electricity, to water, to heater, or whatever. Now my jobs come here. So I want first to test my network to see if it is secure. I want to penetrate it. I want to scan it. I want to hack it to see if it is secure. Otherwise, so the hacker will of course, do my job. So in order to test our network, we have first to understand what are the architecture of the existing network. The architecture of the existing network is same in all other organizations. It is the industrial control system, which is installed here at University of Lille. So the SCADA system that is already installed here in our university actually have the following specification. Look, if I look at this network that you have it here, we have the first one, which is called the corporate LAN. Corporate LAN, it means this is the internal network. And then we have something called here the supervisory control LAN, the second one, which is down. The second one, it means this one is, it's not working, this one? Fine. How to?
First one.
Which one? Not this one, sorry. Here we have the corporate LAN. This is the internal one where the offices are located and all the servers that, of course, here information shared among themselves. They are connected to the internet. Traditionally, The SCADA system was like that. This is, of course, disconnected from the LAN that's local here. So nobody can access the information that is here. But this is an internal system. For example, here, this is the SCADA sample example. Here we have, let us say, the sensors that are connected to a certain, we can see here, EDW. This EDW has the job to convert all the analog signal into digital signal, and then will be sent along with all other signal to the link system. That link system actually will send the information to the control system with the computer. Now, any computer that is attached to that router here, if we can say, or to that switch, can easily attack any of these nodes here, any of these sensors. How? By installing a very simple program on the computer here, on any other computer that are attached here, and perform an attack. What kind of attack? He can modify the information that actually the sensor will, of course, deliver. How? Let me show you how. Hello, we see how here? This is it. Look here, this is a Python script here. It's already published on the net. Anybody can use it in order to hack any SCADA system, assuming that you are inside the company. Usually, internal attacks are more dangerous than actually external attack. So anybody who has that small shell script or shell script using Perl script can attack actually any system. Here are the pins or the coil from 1 to 8. We can modify with these data. For example, here it was 1. I can make it 0, or I can make it 2 or 3. It depends on what are the type of sensor do we have. So this is the type of attacks. What are the disadvantages of this architecture that we have it here? The disadvantage of this architecture are no external access to the supervision network was allowed. Great. And focus on securing physical access to the supervision network and the authorization user access for the employee. So here, what I want you to clarify is administrator cannot see. For example, I am requesting information from the sensors that are here. That are if let us say I am a manager, I want to request information from this sensor. Since this one is disconnected from that corporate network, it means nobody can access. That's why they changed the architecture from this traditional system to a new system, which is actually that system. Now, when they change this one, it means now the manager can access all nodes that are here or all sensors easily from the internet. But what happened now, if, let us say, a certain hacker is, of course, try to penetrate those information here and get the information. So a hacker can easily access now, of course, all the information that are delivered from those sensors. So our main concern is now to make that new network, new SCADA system secure, right? So we are going to propose our own system. We don't want also to rely on proprietary software. We are going to try to always test our network just to, let us say, deliver the best solution. This is the attack, also the hack that the hacker usually perform from where here, from the network. So it attack, let us say, that server, the corporate network, and then it will take access to the supervisory network, and then to the internal server. So he can modify all information, so all our sensors that our colleagues worked on will give false information. So the security issue is not a joke. It's very important to understand how our system functions and how we are going to apply the security measure. We can hack this system because of, I mean soft-wise now, that Modbus protocol is used since 1999. It was originally developed without any security measure. That's why any internal or any insider or any employee that is inside the network can easily penetrate the network. Uh, okay, that we see how sample Modbus attack. Fine. Look here. My suggested solution for the bâtiment A or bâtiment B. And we are going to connect here the two buildings, building A or building what B. So we suggest using, I don't know, I don't want to go deeply or the deep technical. So I want to suggest, let us say, a protocol which is called IPsec. IPsec, it means all information are traveling from one node to another in a secure way. It means nobody can see it. It means they are confidential. But is that a solution? I don't know. Till now, I want to test it. What if, let us say here, we change this node that is here actually to a certain IoT node? You know what IoT node? It means that node will be having here a certain IP address. It means any, let us say, system administrator or any manager can access this through his iPhone. So accessing this through this iPhone, it means the internal network that is inside the building now will be, of course, vulnerable. So what we are going to do, we are going to secure this one also. And for now, I am securing just the connection between building A and what? Building B. That's it. Now, this is a new, of course, architecture that's going to be proposed, that's going to be replace the SCADA system. So the latest technology development and application, which is, of course, the Internet of Things. So what is IoT? IoT, it means anytime, any place connectivity for anyone and anything. Look at those numbers that are coming from Cisco. Number of connected devices actually doubles every 5 years. If you look at 2003, we had 500 million connected devices. In 2010, we have 12.5 billion. In 2015, we will have 25 billion. In 2020, we'll be having 50 billion devices connected. That means our current scheme, which is the IPv4, I don't know if you know about what IPv4, cannot anymore hold this huge amount or bear to, of course, carry such huge amount of users. So all the IoT devices that are currently installed in any industrial control system, they shifted to what do we call the IPv6. Okay. Today's internet is mainly for connecting conventional objects, okay, PC, smartphone, tablet, TV boxes, as usual, you know all of this stuff. Now, connecting a smart object, it's more challenging for connecting smart embedded objects. And those are the objects that our colleagues are going to work in their studies here in our smart cities. So which actually the sensor, the actuator, vehicle, switcher, electrical meter, health monitor, whatever, everything is connected to the internet. What does that mean? It means we are revealing our information to people. It means we are revealing our information. For example, the hacker now can see the lamp, let us say the lifetime of the lamp. Yes, he can see it. So we are revealing our information to everybody through IoT. So IoT is very good, but is very dangerous. The characteristic of smart embedded objects, of course, they are good because they consume low power, large number of devices can be connected, but it is unreliable connection. Why it is unreliable? Since also they design it without taking into consideration any security features. So we have to build our own security feature. Why? Since vendors follow the marketing. They need to produce that devices and sell it just to get or to make money. Those are the wireless access technologies that are currently used. You know Wi-Fi, you know Bluetooth, but the new one is called LRWPAN for, of course, the new IoT systems. I don't want to go in detail for those technical issues, but from now on, we are going to use always IEEE 802.15.4 standard for low rate IoT sensors. Also, those are very technical. I don't want to go deep in these issues, but I want to show you this, which is very important. Our previous system, as you know, follows HTTP. The challenge is HTTP is too heavy for a small device. While the small sensor has actually a processor, it has low RAM, and it has low ROM. So HTTP cannot work. HTTP that we're currently using couldn't work using those small devices since they have very limited, of course, processing capability. So they shifted from HTTP to what do we call the COPE protocol. The all application layers that we are going to use, instead of saying, let us say, HTTP www.lille1.com, whatever. So you will see COPE, 2 : / and you write any IP of the sensors that you like just to get information. Those are also technical issues, but which are very important for people who want to know more about the IoT network. Here comes the issue of IPv6. IPv6 is the next generation internet protocol for feature enhancement, especially to solve IPv4 address exhaustion issue. Great. So IPv4, as you know, this is 32-bit, can hold up to 2 to the power 32. It means 4.3 billion address, and it's already exhausted. So no room in the IPv4 scheme anymore. So that's why they shifted, as I said before, to IPv6, which is 128-bit. 128-bit, it means it can hold up to 2 to the power 128 IP address, which is 3.4 times 10 to the power 38 address. The world population is 7 billion. Each person on Earth can have 0.6 IPv4. Yes, cannot fit for all people. But when using IPv6, each person will be having 4.8 times 10 to the power 28 IPv6 address. What does that mean? Having that a huge amount of IP address, we can have as many devices, and those devices, believe me, they are private devices. We don't have anything called anymore netting, if you know network. Netting, it means I can speak to Danny, for example. My device can speak immediately to his devices through something called machine-to-machine. This is a new architecture. Instead of SCADA system, we'll be having that new backbone here, which is, this is the server, this is the internet here, this is the router connected to our LAN, which is here at our university. Those are the new node which works using IPv6, will be connected to any computer. Not necessarily this node can directly be connected to this node can speak to this node can speak to this. Why? Since each one has his or its unique IP address. Thank you very much.
Thank you, Elie, for this presentation.
Thanks.